Hi guys. So I ate something and then I'm back. We want Ari. He was the only one following part one. Is he here? I am getting sleep, I think. Is anyone coming from the previous stream? I'm trying to continue previous stream. I haven't implemented it. I haven't completed the solution, right? Is anyone coming from previous stream? Happy New Year, guys. Not the CSCS one, but after CSCS we tried a problem that uses XOR basis. Happy New Year, everyone. But I can talk in Telugu. I can. నేను తెలుగులో మాట్లాడగలుగుతాను, but how does that make a difference? Anyway, get bad is was the resolution, bro. Resolution. Getting bad is would be definitely good, but I don't have any resolution yet. Hi guys. We are trying to. No, I don't use it yet. Maybe how to use the X. Maybe how to use X and write some shit so there is some following. IGM dream was for this year and this year is done. I have 63 minutes left to become IGM, but I cannot. How am I mogging? Uh, Suggest me a resolution, bro. The fuck you need resolution to be suggested by someone else? You want your goals also to be accomplished by someone else. You want your goals also to be fucked by someone else. You're a cuck. Have your own goals, okay? Have your own resolutions, okay? I'm not doing it very fast. Guys, I see. Did I suggest me a resolution, bro? You have literally asked me, suggest me a resolution, bro. I'm talking about that. I was telling how the behavior is similar, okay? What do you mean JE prep helping in CP? I have 6, maybe I will perfect my 8. Aren't you at home? No, I'm not at home. Oh, guys, let me explain where we were stuck in the previous problem, okay? This is the previous problem. We had multiple problems here. We had XOR basis. One problem is finding basis starting from position I. Okay, this is one problem. Other problem is finding the kth XOR basis. This is another problem. Let's keep those two problems aside. We have one more problem that I have to think about. I don't follow Telugu that much. I don't follow Telugu movies that much. Like to choose between Prabhas or Rana. Whom would I choose? Prabhas versus Rana. Like the video, guys. It was good. The website was good. Yeah, likely it was good. Which website, by the way? There were many websites. I have checked many. I have checked twice. Guys, like the video. Quickly like the video. How is my development? I have to see. I have to see if I got any text from my work. I'll try to do something else quickly after this stupid stream that I'm trying to do. Total time on, yeah, that's a good one. Why don't you post a blog on CF, like total time on CF? Make a website for me, right? Many people ask that question when we say we do coding. Make a website for me. It's the same for me now. Make a website for me. Like other people have a website for them. Like let's say there are other content creators on YouTube. They have a website, I guess, right? Like maybe like they sell a course there. Yeah, make a website, sell a course in my name. Okay, give me like 20% of that. You can give 80%. Put in all the work. If some work is necessary, I don't think it's necessary. You don't like me selling courses. Guys, please try to follow this thing. If you cannot follow the whole question, at least I will tell you what we can do. We have three problems. Problem one, let's say finding basis starting from I. We have to find that basis from I for all the suffixes. Okay, this is one problem. Keep that aside. You have z basis vectors, let's say. You can find two power basis vectors, right? You have to find the kth value in it. This is second problem, let's say. If you don't understand, try to understand. Like, don't give up in general. Like, try to understand. Will AI help me? Huh? Okay, now we have one more problem. The other problem is, given this value, given one value, given a value x g2, let's say, and then you have b3, let's say, and then you have b0, b1, b2. Okay, you need, why are people texting me? You guys come to talk to me, like you guys come to talk, and once I solve problems, people drop. You, you guys can be helped. Given you guys can be helped because I know from long ago that whenever there is, whenever there is these DSA sheets, these things that you're trying to remember. I know all of these things doesn't help you. They try to feed you. They try to sell you what you want, and what you want is not to learn. If you want to learn, you will learn anyway. But what you want to do is you want to act like learning. I think that's why those stupid sheets or those stupid things, like where you're trying to memorize things rather than trying to improve yourself, you guys will find something that is good to hear for yourself. I cannot explain it well. Like otherwise, you would be doing better already. Okay, let me remove this thing. Let me screen share again. You guys don't do actually important difficult things. That's why I don't have viewers, right? If people are actually improving, they don't want to see, they don't even need to see something, but then they would prefer my videos, I guess, if they're trying to actually learn rather than I think you people also come to talk to me, I think. So we have two problems. So what the question is, there is a greedy way to do things. Okay, we have an array a0 a0 can be a0, a1 can transform into a1 XOR some subset of previous things, a2 can transform into a2 XOR some subset of previous things. Okay, so now we have this is the different possibilities. We want to make it increasing strictly. So what's the greedy way that's possible? Keep a0, keep a1, that is the smallest thing you can get greater than a0. Keep a2, the smallest thing that you can get the previous a1. This is the greedy way. And then if you see in terms of XOR basis, you can see that all these things can be known. How to make them greedily can be known already. So now the problem became, let's say you have some basis already, and then you have a new value called b3. This is a new basis, and you have a value g2. You need, this is problem 3, this is problem 1, problem 2, and this is the problem 3 that is left. And if we have all these problems, we can extend, we can find greedy way, because I was able to find that we can extend this quickly if you can get the kth value. Okay, if you can get the kth value, we can extend that quickly. And so now I can extend this thing quickly. Like if I can get the kth value, I want to extend only this thing. Okay, if I can extend from here to here, then I can extend this again. and then I will extend that thing again. So the only problem that's left is given a value g here, let's call it g2, and you have basis vectors b0, b1, b2 that forms them, that you can use, and you have b3. Okay, why am I not using A3? A3 is nothing, B3 is nothing but A3 XOR some subset, because some subset is already, you can choose some subset. You can also involve some subset, because some subset XOR some subset equals to some subset. Okay, it's difficult to say, but some subset XOR some subset is some subset, so it's fine to use XOR. Okay, are you guys understanding things? Tom Scott, you're showing good interest in things, but can you try to understand? Can you do me a favor by trying to understand the previous part and also this part? Even if you haven't followed the previous part, can you try your best to understand this part? If you can, that will be a great helpful. Like I think even if one guy is understanding, I can go ahead and teach. But if now none of you are following, it's very difficult to teach, right? It's very difficult to have any motivation, right, to try something. So the problem is, I'll try to tell again for your sake. The problem is, you can change a0 to a0, you can change a1 to a1 XOR a0, or you can keep it like that. Damn, you can keep it like that is what I was missing, but that's same as choosing some subset. Okay, 0 is always present. Okay, so how I have solved the problem is, we have this greedy way, and what I mean by that is, if you see basis, only these seem to be the important one, but because all these things can be formed as a subset of previous things, and if you can make a subset of previous things using, so something which is already a subset of previous thing, and then you can add any subset of previous things, so it is nothing but a subset of previous things. And if it is nothing but a subset of previous things, you can see what all are found by subset of previous things. Let's say g2 is here. Okay, and you can form anything that is a subset of previous things. So this value greedily will be g3, this value will be g4. If you can order subset of previous things like this, like that's nothing but ordering basis. So the problem I wanted to solve was, given some basis vectors like jet basis vectors, how to find the kth value, because if you can find the kth value, you can put after g3 thing, you can try to put all of them quicker. Why? After putting all of them, you only want this one, and that would be some kth thing in the basis, like kth thing in the values that can be found with this basis. Okay, so that's why we wanted this problem, and we wanted this problem because we're starting from b0 a0, right? But we start from ai, we start from al, we come from suffix, like we come from this side, and we try to come from here. So when I'm at here, I want this basis. Okay, I want where basis exists. Okay, and for that reason we have this problem. I know it's difficult, but if you should have followed previous part. Okay, you should have followed previous part. Guys, like the video. I have done an ace cosplay once long back. I'm thinking to do it again. I'll show my ace cosplay if I can open my Instagram. I hope no personal information of people is here. That's not me, but that's some guy. I just followed because it is calisthenics. So I have done once ace cosplay. Where am I? Why is it not visible? Yeah, it is visible. I had done this ace cosplay. I had long hair then, but now I don't have long hair. Now I don't have long hair, and I'm trying to do the same cosplay again, but without long hair, it doesn't look that good. Right? The long hair was perfectly matching to that somehow. See, the long hair one was good for that, and this hair, I think it doesn't suit it. Where am I again? What do you mean done? So you guys understanding shit. So I actually have to solve one more problem. I actually have to solve one more problem, which is extending, finding this greedy thing, extending that over here. Extending that over here, like when we get a new basis vector, I want to extend it then. So that problem becomes, given you have a G2, given you have a basis, you need to find smallest thing greater than G2 that can be formed using B3 and some subset before. Okay, this is what we have to do now. And if you can do that, after this B3, if the next basis is somewhere here, you can fill all of them quickly. The thing is, we're trying to extend the thing greedily, and and when we are trying to extend it greedily, we only have to worry about this. And if you can find this, all these things can be quickly found. So that's the problem. Okay, it's that simple. The problem is that simple. So the problem we are left with it is like extending one step. Like you have a new basis vector, let's say B3. You must involve B3. You have to find something greater than B2. Okay, you must involve B3. And you want smallest thing greater than G2. Smallest thing greater than G2. So how to do this, how to do such a problem is, let's say if you have some prefix, okay, if you have some prefix, and then, okay, what I mean is like you have some fixed prefix, okay, and then this exists, which is greater than G2 and can be formed with uh, B3 XOR some subset of B0, B1, B2. Okay. If you can answer this such a question, if you can answer such a question, if you can answer yes or no to this question, then we can solve the problem by trying to answer if this exists. See, I added one more zero. If this exists, if this doesn't exist, if this exists, then we have to proceed further. But if that doesn't exist, then this must be one. Do you guys get what I mean? If you can answer this question, like given this prefix and this can be anything, is there something that can be formed which is greater than G2? Is there something that can be formed which is greater than Z2? Can we answer such a question? Okay, now we have to find such a thing. If this thing can be formed using basis of B3 XOR this. First, what we do is B3 must be taken. So we XOR this thing with B3. Now this thing has been changed a bit. Now we have to see if this thing can be formed using this basis, right? How do we solve such a problem? How do we see if this thing can be formed using this basis? And while you're trying to solve this prefix, if and this prefix should always be greater than G2. I don't know. We have to find something that is smallest that can be formed using these bases. Okay, where B3 must be involved. Am I trying to gain Instagram followers by showing my profile? No, I'm not trying to do that. Should I follow back? No, I don't know. You guys are up. Some of you are totally strangers, right?
I got
What am I doing? So we have to solve this problem. If this problem is solved, we are good. Are you guys able to follow, or are you guys able to think this problem? I know you are not, but I'll remove you if you try to comment shit. Okay. What hurt, Tom Scott? So R is back. We have our only listener, only proper listener, Ari. So he has just joined. So what do we do is, see, I formalized the previous problem. I think you can follow so far, right? We are trying to find the greedy thing. And if you have basis, we can find the greedy thing as much as we can. And we have to find, but where we were stuck was we want to find this one. You must use B3 because you must use A3. And A3 is a new thing. You must use A3. So we must use B3. A3 and some subset is nothing but B3 and some subset, because B3 is nothing but A3 and some subset. Some subset XOR some subset equals to some subset, okay? But one of them is particular subset. Like the other subset is any subset. Because of that any subset XOR some subset equals to any subset, right? That's how we come to any subset. So now the problem, instead of A3, we can consider B3 must be present, and you want the smallest thing which is greater than G2. Okay, you want the smallest thing that is greater than G2, where B3 must be present. How to solve this problem? I was thinking something, but then I am being tempted by this thing. We were able to see that we can find the kth smallest value, right? If you can get the kth smallest value, I'm being a bit tempting. I'm being a bit tempted by, uh, can't I find can't I find can't I involve all these four things and find all the things and see where G2 is, and then try to see something that involves B3 and which is after G2? Like I'm trying to try for that, because we can see, but B3 will be present sometimes and it won't be present sometimes. That's very weird. Like where B3 will be present, like it's like jumbling, like it's like very jumbling. Like if you see the structure again, if you have 1 here, means this is the highest significant bit, right? First half things will have that bit 0, next half things will have that bit 1. And when you come here, because here it is 0, even this will be 0, okay? But if you come here itself, that would be 1. But if you come here, because this is 1, if this value is present here, the smallest thing will be 1, the biggest thing will be not taking that. So the things will become more complex, like not complex, like they'll be like jumbled. So, but we want something that surely involves B3. We want something that surely involves B3, that can be formed by involving B3. How do we do that? We want something that can be formed by involving B3 which is greater than G2. I swear, girl, if you leave, just let me know so I won't look down. So B3 will be like, among these layers, it will be somewhere, right? When it is there somewhere, losing interest, you won't find no better than losing interest. What's wrong with you? Yep, that's what we were trying to find. And that X can be found with previous B's and BI. Only that is left. If I can solve that, then I can. Ah, Tom Scott, you obviously are not a stranger. Like Susan UK is a stranger to me. Okay. What is this? FL5dy. Yeah, that's what we want. Like we want to solve the problem because this problem can be solved. Trying to use previous basis vectors and then try to form basis among them. I think that would be correct. And then this problem also has been solved. How? If you want to find the kth value, we will start with if they involve this or not. If k is less than half, less than 2 power z minus, I mean, it's in the first half, then you won't involve it. If it is in the second half, then you will involve it. Now you have to solve it further. Given this is already present, you have to see if involving this is better or not. If this bit is active in already present thing, if that bit is active, then you won't involve it. Otherwise, you involve it. Based on that, you can move your k further. Okay, and then you can solve the problem recursively further. Okay. So like it's simple. Like based on kth value, right? For kth value, you'll try to see its bitwise representation, and based on that, you will try to make a choice over here and over here and over here, up to so on. Okay. Should you take that or should you not take that? Based on this bitwise representation, you can try to make that choice. So you can get kth value. If you can get kth value, you can fill all of this quickly. You can also find where this shit is by trying to find doing binary search on k. If you know if that value is less than g2 or greater than g2, you can do binary search and get this one's position. If you can get this one's position, you know how many things are after it. So you can find if you can proceed till here or not. If you cannot proceed till here, you will end here. And if you end here, only from here to here increasing is possible. And after that, it's not possible. And then you can answer all the queries that start with L equals to here. And if R falls within, they are yes. If R falls later, they are no. Okay. That's how you solve all the queries. The only problem that's left now is this one. This is the only problem that's left for us to solve now. Okay, greater than G2, right? Greater than G2 can be written as 1110. So greater than G2 can be written as, okay, prefix of G2, okay, and 1 where there is 0 here. So guys, and then there can be anything. So this is a structure. This is a structure, right? And that's very similar to the problem we have taught before. But now this need of greater than 0 has been eliminated. If you can brute force all of these things, right? And we can start from this side. If you can start from this side, why if you are starting from this side? That's the smallest thing that is greater than Z2, right? But if it is present, if this is present, then what should we do? Then we have to find the smallest thing among this. We will come from here, come from here, come from here, and after that we know how to come from this side, right? We know how to come from this side. If this can be formed, we know how to come from this side. If you can come from this side, I mean, how do we come from this side? Like to find if something is possible with basis. If this bit is active, you'll try to XOR with that, and then you will go to this basis. If that bit is active, you'll try to XOR with that. But if you have a bit which is not active, if the highest significant bit is not active at some place, I mean, if the highest active bit is not present in some basis as the biggest one, then you are done. Then you cannot solve it. In that way, you can try to find if all of these can be formed or not. If all of these can be formed or not using basis, then you will be left with something over here. And now the question is, can you also form this thing? but that thing can be 0, right? Now how do you start? Now how do you start? You have some, you have some other smaller basis things, you can just make it 0. Can you do that? No, 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 you cannot make it 0. You have something, you can try to make it 0. So now you are left with something because you try to fix this, you try to fix these things, you're left with being able to form this thing. You're left with being able to form this, not being able to form this thing, you're left with this thing can be formed. Okay, this thing can be formed, you're left with that. Now you try. If this thing can be made 0, you try for that. But then you have to see like, no, we are not getting it yet. Can this be can this be made 0? Can this bit be made 0 and still you have that? Okay, from here, right? Pref of G2 1, we have this one, and these things can be anything. From here we try to see if this can be formed or not, and then we try to see if this can be formed or not. Okay, I think this makes sense. If you can find if this can be formed or not, I mean, all of these things should follow this, and then if these things can be anything, if this shit can be formed, that means this bit should be 0. And then what you do, you will try and proceed further. You will try and proceed with 0 or 1. You will check again if 0 is possible. If 0 is not possible, you will check with 1. That must be possible, right? If you can confirm that this sheet is possible, that must be possible. In that way, you can proceed further. So if you can say if some prefix is possible, you can find the smallest thing that is greater than G2 in some way, right? So we have an algorithm at least. If some prefix is possible, we have an algorithm. Guys, if you can say if some prefix is possible, we have an algorithm. That's what my greater than G2 also will be incorporated into the prefix by brute forcing it in a way that prefix of G2 1 where G2 is 0. If you brute force those things from this side, and if you know if this exists, then we can go and find the smallest thing by seeing if this being 0 exists or not. If that being 0 exists, then we will proceed further. Else we'll make that one and then we'll proceed further. Like, are you guys able to get that? Like, I used to do this a bit previously too. Like, we come from this star and we see if we can answer if this prefix is possible or not. We can answer further by trying to say, okay, this prefix and 1 or 0, is that possible based on what we want, greater or smaller? If that 0 is possible, that means we can go further. Else 1 might be possible because this is already possible, right? In that way, we can find the smallest thing greater than something in a set, or we can find such a thing. Yeah, like a tree, like a try. People use try for this thing. People use try for this data structure. Like when they want to find smallest value greater than this that can be XORed with this. I think there is a famous problem. People use try, but in my first attempt, I was using set, I was using lower bound because if I use these prefixes, it's just lower bounds, right? All I want to do is if there is something that is matching this prefix. Because I wanted to see if there is something that is matching with this prefix, what I did was I found lower bound which is greater than all zeros here. And then I will check if the prefix matches or not. That's how I solve the problem. And the famous way to solve the problem is try. Okay. And I'm using similar idea here. I'm not using try here. I'm not using try here. The idea is similar to try because there is a famous problem of finding if you have a set X, if you have a set and if you have a X value, if you want to find the sum, you want to find if there is something in this set. I'm not remembering the problem. If there is something in this set whose XOR with this is greater than this value, I think it's something like that. Or whose XOR with this is greater than this value. I think something like that. When we want that, we can try to do something like this. Like the video, guys. But here we need not even use set because to find if this thing exists or not, we know an algorithm that is already there. Like it tries to go over, like it tries to look at the maximum bit, and then it tries to apply the XOR basis, and then it returns answer. But what we have the freedom is, we have the freedom to stop. We have the freedom to stop from here. So first we will try to find what is the maximum prefix we can maintain with greater than G2. If that's impossible, we will end here itself. This itself cannot be formed, okay? So guys, you guys are able to see that. You guys are able to see that in this problem, what it involves is, it's a very difficult problem, right? I don't know if it is 26 or 27 or 28 or 29, but it's a difficult problem. 26 is also difficult, but this is greater than 26 because it has many implementation difficulties, right? I think it's greater than 26. Don't check and tell me. I think something like that. Maximize the two XOR values or something like that. I swear, girl, if you leave, just let me know. So where am I again? First we try to find the maximum prefix and then one. That is possible. We come from this side. So that's nothing but answering one prefix query, which is what do I mean. What do I mean by prefix query? If this prefix is possible or not. If this prefix and this. So we have one important problem now. If this prefix is possible with XOR basis. You guys see, just being able to answer this, we don't care what is here. We don't care what is here. Just being able to answer this question is making us solve much more complex things in some way. Do you guys see that? And something greater than G2, you have to actually, what you have to do is you have to just mathematically write it down. What is something greater than G2? Some prefix matches and then 1 comma 0. This is what, and there can be anything here. That is what's greater than G2. And we want the smallest thing. So we want the maximum prefix to match and then 1 when G2 is 0. Okay, and then prefix can be anything. And now if we know that is possible, then again we try to use the same prefix logic. If 0 and then excess is possible or not. If that is not possible, that must be 1 and then that must be possible, okay? In that way we can proceed further and then we will have our value, which is the smallest thing greater than G2, which is possible with the XOR basis, smaller XOR basis, okay? Wait, what happened to must take B2? What happened to you must take B3? Once you try to apply this prefix, once you try to find if this prefix is possible, first step you do is you try to XOR it with B3. Okay, when you XOR it with B3, B3 is already involved, right? Now whatever comes, you'll try to see if that sheet can be formed using the remaining basis vectors. That's how we solve the problem. Okay, B3 is always involved, right? So the problem is same and nice and can be solved. So we can solve the problem. So what I'm trying to say again here is, it's a problem. It's a complex looking problem, but it can be partitioned into three different parts, three different independent parts. You want to extend this greedily. And to extend this greedily, if you are at XOR basis and the new XOR basis is very far, you can extend that very quickly by trying to see the things that can be formed using this basis in an increasing order. If G2 is here, the next thing can be G2. You can make that G2 because this A3 itself is a subset of B0, B1. And if that is a subset of B0, B1, and if this is a subset of B0, B1, you can you can take those two XOR and that will be the subset that gives you G3 here. Okay. So what am I saying? If you can solve this problem, finding the kth value, you can extend this quickly till here. If you can solve this problem of, if you can solve this problem, you can extend it here. And those are the only things that exist, right? A new basis came or the previous basis existing. And to solve the problem for all subarrays, any subarrays, because we have to solve this shitty problem from any L to any R. Any L to any R, we have to solve them, okay? So what do? We want basis vectors. Starting from AL, we want basis vectors. If you know where all basis vectors is there, then I can solve the problem for all of them suffixes, because if I cannot form some G3, let's say if this G3 was impossible, then the shit ends right here. But if these things cannot be filled for this long distance, then that shit ends till here. And once you know till here, only till here it's possible to form, then or less than or equals to that value when L equals to this can be formed. So we want to form basis vectors. Like if we want to know just basis vectors to solve the problem for L, that's why we have one more problem here, which is this problem where if you know basis vectors from I plus 1, I think we can get basis vectors starting from I. Because I think if basis vectors of this or this, I think basis vectors from here will be a subset of that, likely. And then we have basis positions of that too, because this is already a subset of these two things, and if that has been preponed, that means that can be formed with previous things itself. If that thing can be formed, I mean preponed in the sense if that's missing, that can be formed with previous things itself. And if that can be formed with previous things itself, then in between things are even unnecessary. In between things are even unnecessary because these bases itself can be formed with these two. So these things can be found with basis. So those are unnecessary. So basis will only take part here. That's an assumption. That's a famous problem. This is likely a famous problem to find basis of starting from any index. You want to find basis of this prefix, like you want. That's, I think it's a famous problem. I have seen that problem in some other code forces contest, but I was not able to solve it in time. Is this spoiled? I don't know. It's been a while. I haven't. Oh fuck! It's going inside. So guys, we have solved the problem. Actually, I have solved the problem, like the problem was direct to me in some way because greedy is one way. And we can find the greedy itself. And it seems very difficult, but basis vector is the hint. If you look at the subarrays, there are so many fucking subarrays of this form, but the importance is some subset of some subarray which continuously grows like prefix will point you to basis, because most of those subsets are bad, most of those subsets are useless. And once you see most of those subsets are useless, after that you have to again apply logic further that this can be found with previous things itself. So you must use that. You must use involve. So you must involve A3 and a subset of previous things will nothing but it will become nothing but a subset of previous things, because A3 itself is a subset of previous things. Okay. That's another point of logic, like that's the biggest difficulty here, I guess, because I made that, I saw that basis can help and come into picture. But until I made this assumption, that until I made this claim that can you make A3 anything you want, until I made this claim, because A3 can be found with basis, that's one thing that we have to go a bit to a bit higher level. Like if you try to use, if there is a simple solution, maybe this is a simple solution, right? If you can make it anything, that makes this simpler, right? If you can make it anything, that makes it simpler. If you can make it constant, that makes it simpler. So I tried looking for constant, but it should be strictly increasing, so constant is not possible. So anything, like it's either constant or it's either anything, even in such a difficult problem. If you guys see something that was complex, can you make it anything is the question, or can you make it same would be the question. So you guys have to realize that how we use solutions are simple thing. Like when something looks complex and still there is a solution, you have to see that that can be simplified somehow. Okay, that's the core problem solving. Always when things look complex, look for what is simpler. Okay, that's what I use all the time. Okay, so we have simplified the whole problem into 3 steps. Okay, and now when we try to implement such a problem, we feel good. Where am I? My back is aching because I'm shouting. Let me stretch my back a bit. Will it break? So now we'll implement this problem. We cannot implement it before New Year, but we can start New Year with solving a problem. Not exactly start, but a bit of start. You guys might be wanting this, but I'm not giving it to you. So yeah, so and we further simplified a complex problem which is finding the smallest thing greater than G2 that must involve B3 and can be a subset of this. If we simplify that problem into just this problem, which is nothing but given this prefix and this can be anything, is this possible with the XOR basis of this thing? We simplify that to that. Why greater than G2 can be just simplified to prefix of G2 comma 1 where G2 has a 0. This should be one where this is 0 and this is possible or not. And once we know that this is the maximum prefix that is possible, then we try to go and find then we try to go and find if this prefix and 0 is possible or not. And how do we involve b2? The only problem we have is this prefix possible by surely taking that, because you're surely taking that, you will anyway XOR with that. And then you have some other prefix xxxx that is possible or not using this XOR basis. So it all reduces to the same problem, which is can you find this prefix with this XOR basis? We already know. Can you find this value with XOR basis? We have to come from highest significant bit and then we decide if this bit highest significant bit, there will be one thing among XOR bases, there will be one thing which has this which should be active here. Why? If that is not active, you cannot use bigger things. If you use bigger things, some other bigger thing will be present. If you use smaller thing, this will never be gone. So there must exist some XOR basis that has highest significant bit active. And once you XOR with that, this thing will change. Then you try to go find the next, check the next significant bit, highest significant bit, most significant bit, and then that should be present in some XOR basis. That's the way. But that way is similar to if some prefix is excluded also, right? So if you have this function, this O of n function, you can find this in O of 20. Sorry, log n. So this is log n. So in log n you can find this prefix. And then in another log n you can find 0 is possible or not, 1 is possible or not. So it's just 20 into 20. It's log n square in the worst case, because trying to find first this one is log n square. And once you found the prefix that matches the best, then finding all the remaining things is also log n square. It's two steps. First we try to find the prefix to find the smallest thing greater than G2, and then we try to go further. First we are trying to find the smallest prefix that is possible which is greater than G2, and then we're trying to go further. What is the smallest number over here which can be which can be found with B3 must be taken and that. So for all of that we only need this function. If you know this function, we can just try to, this is like very simple and easy, right? So implementations are simple, like they're not complex. So we have this this thing can be solved well. So now I'm thinking, what should be solved first? What should be solved first? Should I solve? So this can be a function. If I have jet basis vectors, hi sir. Yeah. Sure. I'm doing a stream. Uh-huh. Yes, yeah. I'm trying to make a video. Yeah. See guys, we have police visiting my room just for, not for inspection, but to use restroom. Because it's, we have 10 viewers, just 10 viewers. Because there is washroom here, yeah. So I'm trying to solve some problem, some coding problem I'm trying to explain. Some difficult coding problem. Those washrooms are definitely not good, right? They are bad, like very bad.
ఇక్కడంతా కాస్ట్లీ ఉంది, రెంట్ అంతా హోటల్కి దానికి దీనికి అని రెస్ట్ రూమ్ చూస్తే అక్కడ అక్కడ న్యూ ఇయర్లో చేశారు కదా
స్ట్రీమ్, ఎస్, న్యూ ఇయర్ స్ట్రీమ్. న్యూ ఇయర్ అంటే సెలబ్రేషన్ లాగా నాకు ఈరోజు ఓపిక లేదు.
भाई कन्नड़ ಬರಲ್ವಾ?
ಕನ್ನಡ తెలియదు.
थोड़ा थोड़ा ತಮಿಳ್.
I can read Kannada. But Kannada script, Telugu script same. Script same.
ಡೆಲ್ಲಿ ಎಷ್ಟೊತ್ತು ಮಾಡ್ಬೋದು? ಓಕೆ. నిద్ర చేస్తాను. నిద్ర చేసేది ఎప్పుడు? నిద్రలో.
I'll sleep in some. కొంచెంసేపట్లో పడుకున్నాను.
ఎన్ని గంటలకి?
టైమింగ్స్
Daily sleeping timings, huh? I'm trying to sleep early, like maybe 1 or 2, but sometimes it becomes 3 or 4. Trying to sleep early.
వర్కింగ్
Working, sometimes I'll work till 1 or 2, sometimes night, because US company, current one.
డే
Morning I can start from 9. It's flexible, mostly flexible, not very rigid. I'm doing stream, like there are people trying to watch.
ఓకే థ్యాంక్ యూ.
Yeah. My washroom is not public, but I'm in Bangalore. I'm near like Church Street. Like there is something called Airlines Hotel near Church Street. I'm staying in that place. There is a PG, but I'm staying there. Like my roommate is not there, so I'm just alone. But I'm not celebrating New Year alone. We have 20 fucking viewers. So guys, we have to implement all these things and then we are done. See. We can do one thing. If you can find this one, if you can find this one, I mean, if you can find the loss, if you can solve the loss problem, we can greedily find the whole thing. And then without worrying about complexity, we can test it on here. Without worrying on complexity, we can test it on this problem. Okay. That we can do. But I am very sure about this thing. But so we can implement the whole problem too. Okay. So we are left with some simple problems. Finding the kth value. I will stress on finding the kth value. Okay. If k is between half and if k is in the first half, this should be 0. So how to find the kth value? It's nothing but given you have these basis vectors, remove the biggest basis vector. Given you have these basis vectors, if you can find kth any value, you can find for this also. How? Like we are trying to see it like recursively. If k is half, then the problem becomes you should not take that, and then the problem is k is less than half. Same, solve the problem for this. Okay. Solve the problem for this where the prefix has already been taken. The prefix already been taken is 0, let's say. Okay. Then you have to solve the problem for that. So there is some prefix, not prefix, there is something that is already, you have to XOR with. You have to XOR with this value. And then you want smallest things. Okay. Initially what you have to XOR with is 0. But if you must take this one, then you have to XOR with this value. And now you have to find the kth one, kth smallest. Once you are XORing with this value, how do you do that? You go to the biggest active bit possible, and then you try to see if you are XORing this with this value, what is the biggest thing? How do values will come? Like, will you take it or not? You have to try to see that. If you see the first half things, if this is there already, the first half things you must take that. The next half things you won't take that. Based on that, you can make your decision that you're either going here or you're going here. Okay. You have half of the things with this being taken and half of the things with this not being taken. And because you have to XOR with this thing already, you can see if that bit is active. Taking this will come in the first half. Not taking that will come in the next half. Okay. You have something to XOR with. And then you have to see the ordering. That's how the recursion is going. Okay. Are you guys able to understand this one? I'm using this algorithm to find the kth value in an XOR basis. Like if you have a basis vectors and you want to find the kth biggest value in that, I'm using Uh, can we implement this problem? Is there Tom Scott? It's not doing correct XP. Mohit is at the last. So guys, to find the kth element, we can do something like that recursively, okay? So to find the kth element, let me say, I'm trying to think how to represent these basis vectors. Should we try to represent them as where all they are present? Let's say we can represent basis as like something like this, okay? Something like this where b of I equals to 0 means it's not present in basis, else that is basis vector. Okay, if we have this, z equals to number of active basis, okay? We have to come from top, we have to come from biggest bit, and we have to reduce our k. We can do iterative itself. We have some x like hash, let's say, which we have to hash with, and with respect to this hash we want to find kth smallest value, okay, with respect to this hash. So now you come from that side, and in this hash if that bit is active, then first half will be first half will be taking this basis vector, and then you update the hash accordingly. So this can be solved like that, okay? We can just maintain this one, we can have some z, okay? We have to start with something that is greater than 0 first, that is greater than 0, and then we can solve the problem, okay? You know how we use the kth smallest value? How we use it is, we know here g2 is there, and from g3 g4 up to so on we will try to find till where we go, till where till where we can go. This length will give us this value, that length will give us this value, but if that length already exceeds the number of things that can be formed, then we will stop in between, okay? The problem is solved then. At this stage the problem is solved, only till here can be formed, and after that it cannot be formed. So we have three steps. If someone can implement them quick, they can come here. Nice, Tom Scott. You have understood till here, right? We have to implement three things. Okay, first let me try to solve finding basis vectors for all the things. Okay, let's try to write a program that finds basis vectors. Okay, for all. Let's define M. Okay, and let's use vector int of. Can I try to do something like type def this? I don't know much. I don't think this is possible. Leave that. Wait a minute. Leave that. We'll try to find basis of everything, okay? Guys, the first problem has already been there in some code forces contest where we have to find basis of all the suffixes, okay? For that, our assumption is basis of all the suffixes is if you have basis of I plus 1, you can have basis of I. That's the assumption, okay? So let's just write like this. Vector int basis of n, let's say, okay? So first problem I'll try to solve by trying to find basis of everything, okay? That's the first problem. We'll try to find the basis of everything. We try to find basis b index, let's say. And this will be basis index where that is present, okay? This is basis vector, this is basis where that basis is present, okay? Both will be of size 20. So the assumption is we can use basis of I plus 1 to find basis of I. That's the assumption, okay? We can use basis of I plus 1 to find basis of I. So we want a function now. We try to see how we can use functions, okay? That returns uh, that takes I and using basis of I plus 1 it finds basis of I. And it also sets them, let's say. So find basis. This will try to see basis of I plus 1 and finds basis of I. Okay. My teeth is hurting inside. So how does it do that? We have to sort them based on B index, right? We have to sort them based on B index first. So let's just sort them based on B index, okay? Mm, let's just keep it X. If if B of I, if basis of I plus 1 of I, let's keep it IDX. So if that is active, that is not 0, okay? Oh, is it Happy New Year? People are shouting. Happy New Year, guys! We have a new year. Damn, I see crackers. I'm right in front of UV City. Can I show you people crackers? Are the crackers gone already? I'll show you where I am. I'm right in front of that guy's home. You know that guy Vijay Malia's home or Nikhil Kamath. I'm not sure who is that, but I'm right in front of his home. I'm in ground floor actually, and this is where I'm staying. That is street outside, and this is where I'm streaming from the window. What do you mean by location reveal? So I'm staying in ground floor a bit. It will be more lighting, like people will just smoke here, like it's a famous hangout place. People will hang out here. People will hang out here too. They have left some fries and shit over there. That's scary. Don't meet me. This lighting is not good somehow. I'm using a feature called stereo light. So New Year came, guys. 2025 passed without you noticing, without you accomplishing anything. What have I accomplished? How much rating did I gain from then to here? Where am I? Where am I? Where am I? 1 year ago. So I was at 2153. Now I am at 1909. 1909 minus 2153. Minus 244. Damn, this is quite low. 2153 itself is low. 2153 itself is very low, right? What is 2153? I don't know why this have happened to me. Maybe because I'm not practicing. Is that the reason? Happy New Year, guys. 2000 is not that high. 2300 is also not that high. GM is out of scope, guys. So yeah, we come back to this problem. We try to sort them. When this happens, we push them. It's pair, right? What do? We push the basis vector. We also push its location. First, we'll keep the location, okay? How do we get the location? B index of idx plus 1 of I. So why did I do that? I want to sort them, right? So now we have sorted them. Why do we want to sort them actually? Wait, the fuck? We want basis vectors of all the prefixes, right? How does that look like? Ah, that should be fine. That should be fine. Basis vectors of all the prefixes should be fine, right? So now the question is how it now how we solve the problem is you have f dot pushback of idx comma a of idx. Okay. The problem has a q, right? I'll just clear these vectors. So where are we? We have sorted f. Now we have to find basis for this array itself. Now we just have to find basis for this array. Okay. Int val equals to f dot first, where its position equals to f dot second, let's say. Okay. Now we have to see if val can be formed with basis of I or not. We have to see that now. Okay. How do we do that? We want most significant bit of val. For that, I will start with j equals to m minus 1, j greater than or equals to 0, j minus minus. Okay. If val, now we are trying to form the basis, like if val can be formed, if the most significant bit of val can be formed using if most significant bit of val can be formed using yeah, I know that. If this exists, I mean, if we want the most significant bit of a val, right? If this is 0, okay, continue. Now if that is not 0, now we are at this val's most significant bit. If basis of I, basis of j, if basis of idx of j means, what does that mean? That basis vector is already present. Else, if that is not present, this becomes that basis vector. And before breaking, because this is a new basis vector, we have to do something else too. What we have to do? Yeah, we have to make it that, and we have to make b index of idx of j equals to pos. This value becomes that. So in this way, we have actually formed. Okay, if that is already present, what we have to do is we have to XOR it with that. Val XOR becomes basis of idx of j. So now we have our new basis of idx. That's it, guys. So it's the same algorithm we try to do that, but instead of trying to go over everything, we are assuming that going over basis of I plus 1 is enough. That's the assumption. Okay. Instead of going over I to everything, going over basis of I plus 1 is enough is the assumption. Okay. That is the assumption. Now we have all the basis vectors. So this is first part, that's done. Is this clear, guys? Did I make some mistake here? Is this correct? Can you guys confirm? I'm drinking on New Year. I do drink. I'm not like I don't want to celebrate New Year. It's not like that. Two of my friends have asked me. I cancelled last time. I cancelled plans last time because I wanted to do something else, not the stream. I wanted to do something else. I wanted to have some time for myself. Not to jerk off, but I wanted to just use my time to do something better. But not better, like to just have some time is good, right? After biryani, water is so good. I ate lot of biryani. One whole Meghna's biryani.
Happy New Year, nigga. Happy
What
New
is
Year,
it?
nigga. Happy New Year, nigga. Happy New Year, nigga. Happy New Year, nigga. Happy New Year, nigga.
Why should be the first thing that I watch?
Happy New Year.
I do drink sometimes.
Happy
New Year, nigga.
Happy New Year, nigga. Happy New Year, nigga. Happy New Year, nigga. Happy New Year, nigga.
Why that should be the first thing I see? It's followed by nigga. So guys, where are we again? So first part is done. Do you guys agree that this is done? So now how do we make basis? We can make basis of I plus 1 as all zeros. And we should also make this thing as is this correct? So now because basis of the next thing is 0, what happens is we get one value here, and then we don't add anything here, we try to set that as basis, and then we done, we break, we don't have any other values, and from there everything will be formed. So we have solved the first part. Now we have to solve the second part. Given a basis, you have to find solve the second part, which is finding the kth element. Okay, let basis be b and capital B, let it be capital B, and vector int b idx again. Do we need b idx? Now, using this basis we want, using this basis vector we want the kth value that is possible, right? We want the kth index that is possible. So we have one XOR using which hash, let's call it hash because that transforms everything, right? I don't know if we can call it a hash, we can call it offset too, XOR offset. So using this offset we want to find the value of k, right? So first let me try to find z, okay? If b of I z plus plus, let's say. So z is number of things that are active here. If k greater than 2 power z, let's return -1. I think we can make sure that this never happens, but just we are writing this function, okay? Let's keep it 0 based index. Okay, let's keep it 0 based index. Now we can clearly see that this k, how we half k is very close to how we look at the maximum bit, right? So let's come from the highest significant bits. Okay. If basis of, sorry, if b of I is 0, we can continue. We have offset, remember. Okay. Now, so now, we are at the first bit. We are at the first bit where b of I is active. So if that shit is 0 or that shit is 1 decides everything. If k, so finally our offset will be the answer because that's what we have to take, right? If k and 1 power I, not 1 power I but 1 power z, let's say, because z is that, right? Let j be z minus 1. So guys, we are trying to rename them, okay? Because now j bits are there, 0 to j, 0 to z minus 1 are the bits, right? So if k has the most significant bit as active, that means we have to take greater things, okay? With respect to this offset, you have to take greater things. Else you have to take smaller things. So with respect to this offset, you have to take greater things. Now how to take greater things with respect to this offset? If offset and 1 power j is also active, what does that mean? Offset is already adding that bit, and you have to take the next half. That means you should not include this basis vector, okay? You should not include this basis vector. Else, you must include this basis vector to make that shit active. So offset becomes XOR of basis of not j but I. I mean, we have two different things, like we have two different things, okay? Else we have to try to find the first half, like we know where it is in the first half. See, what we are trying to do is we are trying to do see bitwise representation of k, and it represents actually which half it is. Okay. So how does it represent if the biggest thing of if the first like let's say it's k is having z bits, right? K is having z bits less than or equals to 2 power z. If the first thing is 0, that moves it to first half. And then if the next bit is 0, that moves it to again first half. Or else it moves it to next half. So we're trying to see it in that way, okay? We're trying to go over bits, we're trying to see if that is active, that means we are trying to see it in the second half. And what falls in the second half? What falls in the second half is if the offset is active, not taking this basis falls in the second half. So it looks complicated. I'm not trying to find the kth bit. I'm trying to go over them as bitwise representation, and then I'm trying to do things. But you guys can try to spend some time and maybe try to understand it. Did you guys get some understanding of that? Bye, Susan. What's the first drill? Happy New Year, guys. I see many Happy New Years here. Did I get Happy New Years? Oh, I see. I have some Happy New Years. Fuck, I am a bad guy who hasn't wished anyone Happy New Year, I think. I should have wished Happy New Year to people. You know why am I streaming? I want to distract myself rather than waiting on someone's message. That's why I'm streaming. It's not that I am so motivated, okay? So yeah, now we have to, if that bit is inactive, that means we are trying to look at the first half. And in the first half, if offset is active, it's like taking XOR of those two things. Then we have to make that as 0 because that bit is active in B of I, okay? Wait a minute. For offset, we have to look at B of I, but for K, we have to look at B of J, okay? Why? J maps to I, right? If you are continuing. If you are continuing, J maps to I. So offset is the value, K is the position where it is. So, I mean, this is becoming a bit complicated because, but it's simple, like, okay. It's like we're trying to go over half and then which half and then again which half and then again which half, okay. It's looking complicated, but yeah. Written offset. That's it. We can try to test it if you want. So two parts are done, guys. Two parts are done. Find kth is done. Finding all the bases is done. We only have one more part to solve the problem. Maybe there is a simpler solution, I don't know. Should we do all this thing? So we have one more thing. Is this prefix possible? Is this prefix possible? How do we do that? Is this prefix possible? bool prefix possible, let's say, okay, gives us a val to find, okay, and gives us an index border, let's say, b. What does that mean? From val you have to just look till b, okay. After b it is xxx, it can be anything. So from b equals to 0 means everything. Is this still b? Is that possible? That's what this is, okay. Vector int b using this basis. How do we start? We start from maximum bit, right? If val and this maximum bit is active, okay, so now we should form this bit. But if basis of that bit is 0, return false. Else, instead of these, and these are not too many loops, it's fine. Else we have to make val XOR equals to j greater than or equals to b. Our only concern is still this bit, right? Val XOR equals to b of j. That's it. That's it. Prefix possible. And we know if there is prefix possible, we can actually find the complex thing of two steps greater than g2 with that basis must be taking b3. If we have these three things we are done, we can implement the problem. Roast LinkedIn accounts. Like the video, guys. So yeah, let's say we want another function now that takes a basis and gives that uses. We want a function that uses basis, okay, b. For sure uses b val, let's say, which is b3 in our example. In our example, it was b0, b1, b2. Greater than g, let's say. In our example, it was g2. I cannot think of a name to this, so I will give it fun. If the value is -1, it's impossible, okay? Int b val, let's say. Int g, let's say. Vector int b, let's say. We are doing too much. But's fine. But's fine. Now how to proceed? How does something greater than g look like? We have to start from here, okay? If any of this is possible, return true, else return false. So sorry, else return false. So we are trying to see if g till I, where in the ith bit g is having 0 but our value is having 1. We're trying to see if this is possible or not. So something greater than g will definitely follow this pattern, right? At least the first time. That's the beauty of base 2, I think. No, it's true for any base. But base 2 is simple. If g and of I continue. So now that is 0. So now what do we do? We make let's just say let's have our temp pos. We are trying to see the possible thing be z or I. Okay. So now we have activated that bit. We are here. We don't care what's after that. Is pos possible is our question, right? Is pos possible is our question, right? So pos is having till bit I, right? So how do we check that? If prefix possible, if this is not possible, you must XOR with bval. Okay. So pos must be XORed with bval. And then if pos is possible with b being I, using b. If it is not possible, continue. If it is possible, now we have to go further. For int j equals to I plus 1, j greater than or equals to 0, j minus minus. Now we are trying to come from here. Now you know that what is possible is, now you know that now you know that this is possible. Okay. You're trying to make, sorry, I minus 1. You're trying to make this bit as 0 and see if that is possible or not. Okay. So you're trying to see if you can make complement of that. How to do and with complement of that? Or instead I can do with XOR of, I can XOR with that value, I guess. This would work, right? So we are making that bit 0. I hope you guys are getting what I'm doing here. I'm trying to make this one as 0, and then I'm trying to see if that is possible or not. If not, if that is possible, okay, we have to see till j. Okay. If that is possible, we make pos equals to we make that bit 0 in that, in pos. I think here itself we can make all of them as zeros rather than complexing it like this. Okay. Let's try to make it zeros. How to make it zeros? Pos minus equals to pos remainder of 1 power I. I think that's it. Now I need not do this complex thing. temp equals to pause. I'm trying to activate that bit. Okay, I'm not trying to activate that bit. If it is possible, we are good. We can proceed further. But if it's not possible, we must, because till here is it was possible. So if 0 is not possible, 1 must be possible, right? So what should we do? Pos XOR equals to 1 power I. We don't even need temp here actually. Temp has actually been temporary, has been removed from our code. So guys, do you guys think will this get accepted? So we'll have our answer here. Not even true, we have to find the actual value. We'll have the actual value as pos, the smallest thing that was possible. And the complexity of this function is of m times m square. Are you guys there even? I'll do AMA. When I become Grandmaster, I'll do AMA. It takes 2028, okay? I used to code more in 2023. It's 2026. I'm not even coding now. I'm just doing this for time pass. If you guys think I am retired, if you guys think someone else like Priyan Chagarwal is retired, I am also retired. So we have to have one versus one. I'm just joking. Where am I? So will this give correct answers? Do you guys think will this give correct answers? I think we have implemented it, right? We have implemented it one by one. Wait, we have to XOR it always. We have to XOR it always with B val before testing it. Right? If this prefix is possible, we have to XOR it with B val and then only you have to test it. Okay? Here we have XORed it already. But yeah, from here we have to do that. So this is correct, I guess. So we have everything that we need. We need one more function actually. We need a function that says the position of some G2 in a basis. What is that? We want like this inverse. We want inverse of this thing. Okay. We want inverse of this thing where we get the position of that in the basis. I mean in that basis. Let's use a function to even know the size. Okay. Int get size. Vector int and b. Int red equals to 0 for int I equals to 0, I less than m, I plus plus, if b of I, red plus plus, return red. Let's use that function over here. So you guys think, right? How can competitive programmers be good at development? Because we have to think of the whole problem, and then we have to see what are the parts involved, and then we have to come up with a simple solution by writing functions. Or so I don't mean I'm good at development, but I'm thinking we are capable, like. But I want, at least that's good to assume, I think. So, oh. Even this can be simplified. Small functions, I guess. We will write one more function which is inverse of this function. Like given a value, it tells me its position in that array. Okay. How do I get that function? I'll just do binary search. Okay. Given a value G in basis B, get its position. It's possible to get G using B. Assumption. Okay. Find pos. It takes val, let's say, instead of G, let's keep it val. Comma, vector int B. what is any here? It's not too big. I'm hope it works. Hope it works. I'll do binary search. So left be something less than or equals to val. Okay, left is always pointing to something less than or equals to val. Right is something greater than val. Okay. Left is something that is pointing to less than or equals to val, right? If this is less than or equals to val, left becomes mid. If that is greater, right becomes mid. So left is always pointing to that. We have to return left. Less than or equals to. Biggest thing that is less than or equals to, right? So this is n square complexity. So now we have everything we want. So now we have everything we want. Everything we want. Now we have to solve the problem. Guys, can this be implemented? Like, will this work? Do you guys think the solution is even correct? If there was some mistake in the solution somewhere, it's gone. I don't think that works. Binging like Netflix will not work. What if there comes something? I'm just joking. Like, it's a temporary distraction. But because of here we need intense focus, right? So I think here we don't get much distracted. I think it's going deep into something. If Netflix might be, I don't watch any TV series, but Netflix might be a broader thing. Like it involves broader things. Like it makes us think about something else too, for sure. Because we learn about life, we learn about world. We have no life. We don't see, we don't touch grass. But yeah, it involves grass and world. So what happens is it involves life. So it automatically thinks about things, makes us think about the other things because it's related to that. But this, where do you find bases? Where do you find bits? Where do you find finding the kth element in somewhere? I mean, not even about that, but you have to go deep into the problem. Like you have to think a bit deeper here. Like I think this gives you more, like this takes you deep into something, I think. I don't mean this is fun. I don't mean this is fun. Just because I name something fun, I don't mean I prefer this. I prefer porn over this, but if I jerk off that has some complications. That's why I don't do that often. I don't mean to say like I live for coding, like it's difficult. I just don't know. I wanted to, so I started this problem. I want to solve this problem. That's it. That's all it is. If I haven't shorted it, I would not be doing this. That's all it is. So now we have to solve the actual problem. So where do we come from? So let's take the array A. Okay. We need array A to form the basis because we are using array A somewhere here. In find basis, we use array A because that's the basis, right? That's the thing we try to use everything from. So for we have to use array A for sure. And then we have to store the queries, I guess. Let's just store queries with their or value and query l comma or comma I goes to queries of l comma l l has or comma I. It's like that. Okay. I equals to 0, I less than q, I plus plus, int l comma r. Let's make it l minus minus r minus minus. Let's try to push of l dot push back of r comma high. So now we have queries. Now we have to solve the problem for I equals to n minus 1, I greater than 0, I minus minus. We have basis vectors. We try to go over them. We try to extend our g. And if we cannot extend at some point, we end. Okay. So now we again have to form something like this f. We again have to sort them. Okay. We want this order. We want this order like how the basis vectors have been formed. Okay. Why not just maintain this, you may ask, but I don't know, like I thought this is a better way to maintain. Why not just maintain idx comma that? But then again we want the mapping, right? If I have to do this I think again have to know what the mapping is. Like how to know if that jth bit, I want jth bit, how do I access it quick? I cannot access it quick, right? So there is a trade-off. We must do that sometime. Okay, I'm sleepy, I'm talking while I'm sleeping. So where am I? I'll try to find those basis vectors. But why should I find those basis vectors? Why? Tell me why? I think I could have used a of n as uh, 1 power 21. I think I can use today's stream is almost done. Don't leak the problem rating. 26 is low. I thought it's 29 or something. So we are entering 2026 with a 2600 rated problem, guys. 26 is low rated. Like, I think this doesn't have much logic. That's why it's a low rated problem. Maybe this doesn't have logic. This is having only work. Stupid work, I guess. It doesn't have much logic, I think. Maybe there is a simpler solution. But I don't know. Like, I don't see a simpler solution. Okay. We try to form this F. I used correct variables right above. I used idx here, I used I here, and then I have been pushing correctly. Yeah, that's right. So will also sort this F. And then what do we do? Let's just this be size z. If I equals to z minus 1, I think we want the next end, right? We want the next end index. So let it be e. I'm not even able to name properly now. F of I plus 1, I plus 1 less than z, f of I plus 1 dot first else, let that be n. Let that be the boundary, okay? So when we come next time, we start from here, okay? So now we have from here to here. Now we have from here to here, okay? Now we have from start. We have to find now greedily from. I can make the last previous g as 0 and start from here, and then we start with something greater than 0. Or I don't think this is getting accepted, guys. We should not have started this because they are greater than 1. I could have made previous of g equals to a of I. And start from 1 because the initial value is anyway a of I, right? So that is the first value. Now we are trying to get. But if the next value is also a of I, both will be same basis, right? So I don't think this is correct. We start from 0 because anyway, if the first value is greater than 0, right? Fuck. I hate such implementation problems. No, I don't hate them, but now it's irritating, right? We have this B0 and then we have to see how many things are there between these two. How many things are there between those two? You support 2 power 1 things, right? I don't think this is 26. 26 should be easier, right? Why is it being this big? I think there is an easier solution. I think there is definitely a direct solution. But I don't see it. I don't see a direct solution. So you have basis as 0, let's say, nothing can be formed. And you are here. Okay. You are at the start of a new thing. You are at the start of a new basis vector, okay? You are at the start of a new basis vector that goes till R. So you are trying to make the first thing here. When you're trying to make the first thing here, what you have to use is this function you have to use, fun. You must take this You want something greater than 0, you have to use basis. Okay, what's the value? Int 𝗏 equals to fun of b-val will become, let this is b-val, basis val, let's say f of I dot first. Okay, I'm sleepy, guys. I may make some mistake here. We want it to be greater than previous g so far, whatever that previous g is, right? So we're trying to find till where it is possible, till where from L, starting from I, till where is it possible is what we are trying to find. Okay, we're trying to take this fun and then we'll try to see the so far whatever the basis vectors that have been. If car g equals to minus fun or max, let's say, okay. So it's failing in the first part itself. Wait. First is val, right? Second is val. First is index. This is index. So it's failing here itself. We can break. So it is failing here itself. It's not trying to proceed further. So what I mean is we are trying to go over these things. Okay. We are we are Charlie Kirk. We're trying to go over these things and then over these things and then over these things and then over these things. So when we are here, we are trying to see if this is possible or not. Okay, if that is possible, now that that is possible, now that that is possible, we have to actually update basis with that value. So how to update basis with bval? We have to see its highest significant bit. How do we see its highest significant bit and update it? B of j equals to b val. I think that's enough. This thing could have been optimized into a function, not optimized, could have been made cleaner into that, but yeah, now we have that. Now we have that basis thing, and we have these many elements from, we have things from, uh, I don't want to name it L for confusion. Now we have things from, what is the position? Let me make it L. Okay. This L is different. Don't get confused. We have L to R being open, L being closed. We have to see if you can get all of these things or not. And using basis P. Okay, let's find the position of L. Pos car, let's say, in 2 power z. Z be the size. So we have Z here, and then we have a new Z here. And we are using this Z here, and then we are initializing a new Z here. That should be wrong. Total. Be these many is the total number of things that exist, right? So now we are trying to find, we are now trying to find, are you guys understanding what we are trying to find? In this basis, we have this value called 𝗣𝗁. We are trying to see for 𝗣𝗁 to till 2 power total, like till total. What are the values that are there and where the R will fall? We are trying to find that. What is position of 𝗣𝗁? Do we? How do we have viewers? I have. I'm. What? How do you assume that I'm not having any fun? I'm having fun. I'm having fun for sure. Do I look like I'm fun deprived? I don't have a girlfriend, but I I I don't have an official girlfriend yet. But I have had or I had some fun. Let's say. Okay. What do you what do you guys mean by that? I'm sleepy, guys. Don't care much about me. Whatever I say, I'm sleepy. No, I didn't leave my job. But are we doing something right? We want the position with respect to 0 comma 2 power z, 0 comma total from 0 to tot. We have values from closest 0, what the fuck, closest 0 to tot. We have till here. We have post car. How do we get that? Find posts. This can be formed using that basis because we have used that to find fun where we for sure involve bval. So in that basis that is definitely present, and if in that basis that is definitely present, that value will be within this. Okay, tot, not tot. What should we do here? 𝗣𝗁. So this satisfies our assumption actually. Okay, and if it satisfies our assumption, now we have to see, now we have to see from this position 0 to tot, pos of curve to here. If pos curve maps to L, what does tot maps to? We have to find that. Okay. If pos curve maps to, so we have to see from pos curve. If pos curve is starting from L, where does tot start? Int or lost. Why am I calling that or lost? That's the lost value that you cannot take, right? That's another bound for or. One bound for or is that one, and the other bound for or is this one, like the end of the values. You cannot keep anything higher. Using the same basis, you cannot keep anything higher. If scar matches to postcard. 1 minute. Okay, how many more you can have? What the fuck is happening over there? At least I'll close my window. Guys, it's a simple thing. We have L to R, we have postcode, we only have values till tot, from postcode to tot. That should be a bound. So what is R lost? It should be post, it should be postcode, it should be tot minus postcode plus L. So now this is an R lost, right? If R lost is less than R, that means we are ending before. So R max will be R lost and then we can break. So guys, R max is also like an open bound, like that is not possible. Okay, that's not possible. That's an open bound. This is a closed bound. This is an open bound. Okay, I'm trying to do it like that. Even tot is an open bound because 0 is a closed bound, right? What value does tot correspond to? Post this corresponds to L, this corresponds to that, which is not possible. And if that not possible thing is within, so what I mean is, if not possible thing is within, why did someone ruin like this is just 2600? If not possible thing is within this, we're trying to output, we are breaking it right now. Okay, if not possible thing is after that, then what do we do? Then we find, then we find R minus 1. We find R minus 1's value, okay, because R was the next thing. We find R minus 1's value and then we keep that as G cur. Find kth of, that's the last G cur, right? So guys, if you don't have anything else, L itself will be that value. If you don't have any elements here, if R is the next thing, then L itself will take that value. Cur G equals to find kth of R minus 1. Comma B. In this way, we will eventually reach to some R max, right? And if you don't reach any R max is almost equals to N. Everything is possible. So should I keep R max as N? Assuming everything is possible, and then if it fails here, it failed, and then we will exit right there itself. Else, if it has failed in between, we exit from there. Else, we proceed to the next stage. In the next stage, what do? We try to see it again and again and again. We have R. That means we never have, if we have never braked, what does that mean? Everything was being possible. Okay, in that case, we have our R max itself, which is N. So I think now this is fine. Now we have to go and see over our queries. And we can answer our queries now. Do you guys think this will pass? For sure it won't pass because there should be some error, right? When I wrote this long code, there must be some error, and I haven't even wrote it very confidently. Like I haven't even focused. See, it's having compilation errors. What do they mean? What the fuck do they mean? I have initialized vectors before, right? See? What happened? Till where does it pass? How is this failing? Wait, why is L big? What is this shit? We got S, yes, no, no, which is an obvious wrong answer. 1 comma 1 is S, 1 comma 2 is S, 1 comma 3 is no, is what it is telling. Right? Oh, this is annoying. Let's debug that. Okay, let's debug that. How do we debug that? When I equals to 3, we will try to see that where all the basis things are there first, okay? Do you guys have hope to try this shitty problem? Bad videos. I'm not enjoying to. We have to debug it here. We have this I here and then we have another I here. But this I is not used again, so that's fine. We are only using this I, so that's also should be fine. So let me print them well. Okay, we are starting from there and then we'll try to print all the things that are happening here. And we're not be breaking. For now, let's just print this thing. Like, let's just print F. Let's just look at basis, like if it's being correct or not. Starting from I equals to 0, we have basis at what is this? How can B index be how can B index be same? How can B index okay. This is that. But still here, even here, how can B index be same? B index is corresponding should correspond to different values, right? I see this should be F dot first. This should be F dot second. Value is second and index is first, right? Have I done the same over somewhere else too? Have I done the same mistake over else, like over here? Value should be index is first, value is second. Yeah, I've done it right here. So now we have all S. Let's run this shit. We have all S. We have no S. S. There are mistakes here. What is the expected answer? So what has gone? Third one is wrong, right? Let's look at the third one. 2 comma 3. We can look at something big too. 5 comma 8 is a bit big. Okay, let's look at 2 comma 3 itself. 2 comma 3 is a short example, right? 2 comma 3, the answer should be yes, but we have written no. 0, 1, 2 comma 3 is this. And in 2 comma 3, how can you make it increasing? You cannot, right? Did I read the problem wrong? Have I read the problem wrong? How can you make 2 comma 3 increasing? Guys, how can what? What equal is equal allowed? How does that change the problem? I think that changes the problem quite well, right? That changes the problem quite well. That changes the problem entirely. That changes the problem entirely because now we don't have the restriction that A2 must be chosen, right? Now A2 can also be ignored. Guys, this is a difficult problem. I think that's a simpler problem. I think this is a much more difficult problem, I believe, because now even A2 can be removed. So we don't have the restriction that A2 must be present. That's why it became much more difficult than it should have been. Do you guys see that? I thought we can only add previous things, but we can even add that one. So the problem becomes it's a subset of itself. It's not a subset of this and previous things. I thought it's a bit more difficult. It's just a subset of all the things until there. That changes the problem entirely. Like, that makes it a bit more easy, I think. That makes it a bit more easy. Let me make a copy. So we have to read the problem well before attempting to stream it. Okay. So now what it has done. Until here. Okay, A1 also cannot be taken. Why did I make this mistake? A0 can be 0 or A0. A1 can be a subset of A2 can be a subset of prefix till here. And the same logic is actually true. So now this is just some subset of till bi. A0 is not fixed. A0 can take the smallest value possible. A0 is 0. A0 will always take 0, okay? And now if you think A1 can be the smallest thing greater than A0. That is the greedy way. And if you see basis, okay, B0 is a new basis and A0 can be starting from 0. And because it can be starting from 0, it can go till here. Till here it just tries to see how much does this shit change the problem. You can use this or you need not use that. So the problem is just something greater in combining these two things. So it simplifies a lot. We don't need this big function that we were doing. We know we don't need this function. Guys, we don't need it simplifies a lot. We don't need this function. We don't need this function. Why? We can directly use this function itself. We can directly use this function itself. Like it simplifies the problem a lot. You guys realize that it simplifies the problem a lot. It simplifies the problem a lot. No, the thing is, this is entirely different problem now. Like, not different, like, this is a much simpler problem because we don't have the restriction that we must take B, right? We don't have the restriction that we must take this thing, right? We just the other thing is enough. I do such mistakes in contests, I think, sometimes. But yeah, this we should have been much careful with reading problem. Like, we cannot make such mistakes. Like, okay, so now how do we do when a new basis comes? Now, how do you do when a new basis comes? See, that was the tricky part, right? This was the tricky part I had for most of the time. This was the main tricky part I had. The other thing directly comes from basis. The why it looked complex was we have to use only previous thing. That was the main tricky part that I faced mainly. So, but now it's not that tricky, let's say. So we can, from here we can make all of them again. We'll come till here, and then when you are here, it's same problem. Like, it's a much simpler problem. You can use this, you can use this, just the basis has been updated, and then you have your previous value, and then you can get the +1 previous value. That's it. With respect to this, get its position, get the +1. That's it, and then done. You need not do complex thing that you are doing, which is the complexity involved here. You need not use your fun to get that. You can just do +1. You need not use fun to get that. Okay. And what about the previous? We can start from, I don't know how to use previous thing can be 0. If prev g equals to -1, let this be 0. Else, because curve can be 0 then. Else, we need not use fun. We can just use the same two functions. Get, if previous g equals to -1, let curve g be 0. Else, okay, we can use this now. If kth size is greater than or equals to, then it gives -1. So this is being useful now. So else what we should do is, but that fun was like, that was the main part. Like, that was the difficult part we had. We have to just see this previous g with respect to our new basis. Okay, what we have to do is we have to add new basis to the vector. Where have I done that? I have done it here. Okay, I have to add new basis to the vector. After adding new basis, we can try to see its position. Its pos in new, let's say. Pos of the previous thing in new. Okay, in the new basis, its position. And then we'll try to find If this value, if this exceeds the range, it gives -1. We have checked that here. It gives -1 if that exceeds the range. And then it ends. If it doesn't end, we have that, we have to use the same basis, and then we will see how far we can go. So guys, the most of the time I have spent actually on working on this shit, because this one seemed very difficult, but this one seems very direct. Like this one, like I took break because I thought I had to solve problem 3, but problem 3 has never existed. Like one more problem has never existed. Like solving the above two things was enough. Like this is so specific problem that was not necessary actually, because I have read the problem wrong. If this was less than instead of less than or equals to, that's a much difficult problem as we have seen just now. If this was less than, that's a difficult problem. That's much difficult problem than less than or equals to, because it involves higher complexity of trying to do this one, because otherwise we cannot do that one with just these functions, these two functions. Right now these two functions are enough. This one function is enough. This is just binary search. This one function is enough. Now finding the kth element. Let's see now here. Yes, 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 yes. No, triple S, no, no. What is the expected value? It's still going wrong, but we can debug. But we can debug. There should be something else wrong, right? We can debug quick somehow. I think we can debug. We have everything. Yeah, let's try to debug. What is the expected value? No SS, no, no S. We can try to see 5 to 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, start from I equals to 5. You have two basis things it seems. Okay. One is 5 comma value being, okay, 1 minute. Starting from I equals to 4 you have to see, because 5 to 8 is 0, 1, 2, 3, 4, right? You have 4 comma 3 and you have 5 comma 1, and that's it, because other things are 1 comma 3 repeating. You have only these two things as basis. So you make this thing as 0, and then you try to make this thing as smallest possible, which would be 1. And then you can make this thing as 2, and then this thing as 3. So why did it go wrong? 3 and 1 are enough to form 0, 1, 2, 3, right? So what happens would be this thing will take 0, and then the next thing is a new basis, it will take 1, because 1 is actually possible in that basis. And then 2 and 3 are both of them are possible in the new in that basis, right? So we'll see what went wrong actually here. We can output or max to see that. I equals to 4. It says R max is 7. If R max is 7, it should be S, right? Oh, R max should have been 8. R max should have been n. R max should have been 8. Why does it say R max is 7? How less charge? I'll try to charge it. Guys, this is a much simpler problem than what I was trying, but yeah, let's try to just debug this. What is position of curve should be? Position of curve should be position of curve should be, what is curve G here? Curve G is 1, right? Position of curve should be 1, and then 2 and 3 are possible. Or we can just output tot, because we can compute this thing. Oh, we have preview G. Why are we not updating preview G? No S, no, no. This is entirely wrong answer again. Hello. Not doing much. This is not. I'm just streaming. Yeah. Debugging something. Bye. Uh, R minus 1. This should not be R minus 1. That should be something else. That should be what? That should not. This is not R minus 1. That should be what? What is that value? What is that value? If pos cur is at L, what is that value that is at R minus 1? Minus L plus pos cur, right? We have slightly correct answer now, but it's telling no and it's telling yes. 5 comma 8. What is the last one here? It's again going no for 5 comma 8. And 5 comma 8 is I equals to 4, right? What have happened here? Yeah, started with 0, 0, 2. Okay, 2 power 1 is 2, but this should have been 4, right? This should have been 4, right? Have to come from bigger side, I think. Why am I making such mistakes? Like we have to come from bigger side, right, to find a new basis. Still giving no. But let's see. It's telling 4 from here itself. This should be 2, this should be 4, right? And then why is our max still 6? And why is postcard 3? I'll also output I to not have much confusion. That I is different, this I is different, this I is different, that I is different. 0, 1, 0, 4. How the fuck is this 4? This should be removed here and this should be added here, I think. Okay, why this have happened was I was trying to add that thing after, right? Because that thing should not be added before that. That thing should be added after that. That's why I was adding it here. But because our problem has changed, we should add that before itself. We can add that before itself, okay? So I was adding it there and then here, and one of them is reverse and the other of them is reverse. That was an error. And it's still an error, but we can debug now. So this is correct, 0 2 is correct, and 1 4 is correct, and after 0 the cur g should be plus 1. But why is it not plus 1 is we have to see. What is previous g? So I think previous g is being wrong. Okay, previous g was 0, so what have happened to cur g? Why did it become 5? So prev g was 0, and then we will fed pos in new is 0, and then find kth of 1 should be 2, right? Sorry, should be 1, right? So Karji should have been 1. Why is it 5? 146. What the fuck is 146? So pos in new is 1. How is it 1? That should have been 0, right? If brief 0 is. How is that 1? If that is 0, how is that 1? I'm fucked. I should not be doing this. Why am I doing this to myself? Is find kth wrong? So find kth has an error. I think we have basis already here. 3 comma 1 is the basis, right? Okay, that is definitely wrong. Let me try to find one error in that, and then if I cannot find, then I will try to do that. Z equals to this, K equals to this, V of I 0 continue. Guys, you have to sleep, I guess. Leave me and just sleep. Don't waste your time like this. So what should I do here? I should be doing J minus minus after every each of this thing because J is a different pointer, right? How to do J minus minus? How am I missing such things? Is it because I'm getting old and I think I'm not having practice. That's the reason I think. So now their vowels are correct. And if vowels are correct, answers are also right. But one thing is clear, like this should have been much simpler. right? This should have been much simpler, because now we can actually, it's a direct problem if you see, when compared to what I have done in the past, right? The thing is, this, I don't know if it will get accepted or not, but this problem took much more time. Compared to that problem, made it much more complex compared to the actual problem it is. Okay. Stuck in, delivered to wrong address on flight. Will it go wrong answers on where? If it has went till 5, will it go further? Will it get wrong answer, time limit exceeded? Is it TLE? They shouldn't be giving TLE. It just uses this function and that binary search function. What the fuck does that mean? So we can't know that. I don't think it can go TLE anywhere. What is complexity? 20 into 20. 20 into 20. 20. Is 20 into 20 that bad? Okay, it's 20 into 20 into 20. Maybe it is bad. Would that be the reason? Maybe it is bad. So can we find the position of something quicker? I think we should be able to find. We need not do binary search. We can find the position quicker. So we'll try to do something like this. Okay. We'll look at it with respect to the highest bit that is possible. Okay. How to do j minus minus? Keep in mind that. Okay. This should be simpler, I guess. Will we have offset? Yeah, we will have offset again. So now what? What does offset means? You're trying to find the position of this thing. Okay. If so, oh, if b of I, if val of I, let's say, okay, if val of I, if that one was active, okay, if that one was active, that means you have to try to take the second side, okay? Else you have to try to take the first side. Not the second side, else here it depends on the 1 minute. Yeah, how do you just try to take the second side? That's it. So have to take the second side, but if offset is active, that means you should not. If offset is active, you should not add this thing. Okay, if offset is inactive, you're trying to activate that. And if you're trying to activate that, you have to add that thing. So you have to add offset b of j to the offset, b of I to the offset. And you have to see ith bit because that's what you're concerned about, right? This j is different. That j just represents b of I's position. Here you won't do anything. Here it should be on this side itself because value is not present. The value that is controlled, that's not present. So it should be on this side. But if offset and 1 power I, that means it should be on this side. And if it is being on this side, the offset is already having that. You have to take it to reduce the offset. What happens to val? Is it all right? Is it all right? How to think correctly rather than guessing that this would work. How to think correctly. How to think correctly. Like, okay, val is the value you're trying to find to. And what is offset again? Offset is the thing that will be applied to the things you choose from here. You choose or not choose some basis. On top of that, offset will be applied. Val is still val. If val is active, that means in this, at this basis level, with respect to offset and taking or not taking, this will become zero, this will become one. So val decides it either be here or it's either val decides if it will be here or if it will be here. Okay, but then it should be wrong. But I'm only doing val wherever I mean, this answer seems definitely wrong. But I'm not getting it exactly. This answer for sure seems to be wrong, but how should answer be activated? Is it that simple? Is it just this simple? His answer is just this simple. Then why the other thing is not that simple? Like the above thing. Is it like whenever answer val is active, trying to make answer active? Is that it? Wait, is this not needed? Is this not needed? Is it just wherever val is active, this should be active? Is that it? Then why the other thing is not simple? It just seems that simple. Maybe this is simple. Maybe because to get the value, there will be some other unknown bits, right? What do I mean by other unknown bits? I'll try to comment that. I think to get that other unknown bits, I needed that, but to get this, maybe it's not needed. So guys, I have complicated the problem. I have complicated the problem much more by thinking only previous things can be added. I have extended the problem to all of this thing. Like it was all not there. All of this was not there. All of this was not necessary. I think actually this has made me stuck. This has made me go to eat and come back. Do you guys see that? That has made me to go eat and come back because that's another step, right? That's a difficult step, right? Like that's a completely separate thing. Like it's not the same thing. Happy New Year. We got Happy New Year anyway, finally. Is anyone there? Happy New Year, guys. We have read the problem wrong. It's a stupid easy problem, right? I have read the problem wrong, I guess. Like I have read the problem wrong and then I have complicated it. Like I haven't complicated it, I was solving some other problem. I was solving a much difficult problem which had this complexity of the third problem. The third problem was difficult to figure it out. Like this was difficult to figure out. Like smallest thing greater than G2 using these things definitely uses this thing. That's complex, right? Use everything was already there. We use everything was already done here. Like trying to get that one. But actually to get the actual value, you cannot just you cannot just take those bases. Like offset must be applied because there will be some other ones. Okay, but wait, can we ignore offset? I'm doubting it. I mean, you have to activate that bit is true, but how do you activate that bit? And to activate that bit, should you involve this thing or should you not involve this thing? This must be done here. This must be done here because these things can come with some separate bits that hang on to those bits, right? And you don't know if you have to take that or not take that. You have to put one here, but this must be done. But here we need not do that somehow. Find pause quicker, we need not do that. So we don't need this, we don't need this. Like it's a much simpler problem, guys. It's a much simpler problem. We don't need all of this. We don't need all of this. We don't need all of that. This all of this is not needed. And that one took much more time for me. See, the whole problem is different. I'm doing job from 1.5 years. Even I use phone, right? Okay, give me any other problems. I'll solve any other problems. I think this is not that high rated. I expected it to be high rated because it involved three things, but it involved only two simple things. The third thing was more complex. Right. The third thing was more complex. This involves only two small things. The problem I have solved is much more complex. It involves prefix possibility, it involves fun, it involves that is much more complex than this problem. Because there I had to come up with this new idea, right? But this is like very direct. It's like very direct. It only uses that only basis are important. And it uses two things. This basis, finding basis for all things, and then the other thing. So it is much more simpler, guys. I should not have complicated it. Give me one problem. I just removed my beard. I'm a very old guy. I'm 32-year old. Division 2 is it. Expected product for a given integer a of length n. Integer array, for a given array of length and find a parameter k, define f of a comma k as follows. Consider a random experiment of the following time. Repeat the following action k times choose an integer index I uniformly at random. From here update ai by ai plus 1. So what we do is choose something uniformly random and then we update it by plus 1. After all k updates, define p equals to that. F of a comma k is defined as expected value of p modulo this in the above random experiment. You're given an array a of length n. You have to find the answer q queries of the following type. Given L, R, and K, find f of A, L to R, comma K, where L to R, comma K is the subarray. So the problem, let me paste my golden rules over here for, okay, I can try to do this. So the problem is, first solve if L equals to 1, comma R equals to N. How do you solve that? That's the first problem, right? What is the answer to that? You have to first come to here, okay? If you write literally what is expected value, uh, it takes all configurations, right? You have initial a 0 plus some value v1, let's say a1 plus value difference, like let's call it dx, let's just call it d1 d2 a2 plus d3. Let's try to write it like in the most simpler way we can. dn, okay, we have sum of d equals to k and all of them are uniform, like all of them are uniformly chosen, right? Like you have, how many possibilities do you have for this thing? How many different possibilities, in the sense not even different possibilities, like it's like blocks. Like if okay, if you're having d1 value here, how many times that d1 can come here is, it's like ncd1, like kcd1. I think it's like k factorial by d1 factorial d2 factorial. What I mean is, like, you have to see it like k balls are there, okay? K balls are there, and then you have to color. If you assume that d1 things are coming here and d2 things are coming here, how many times d1 things can come here randomly? Like you have n possibilities, right? And d1 things are coming here. Those d1 things can be anywhere over there, right? So how many ways that can happen? So you have k balls, okay? Each ball can come into either this or this or this or this, which is nothing but you can paint each ball into either this color or this color or this color or this color. Each ball can either be gone into this, to any of these things, okay? But it's not even counting. Let's still try. If you expand this shit, because d1 is a random variable, right? If you look at it independently, d1 is a random variable, d2 is a random variable, d3 is a random variable, up to so on, dn is a random variable. Like all of them are not independent random variables, they are dependent random variables, because you have you have a clear dependency here. I mean, it's not about random variables. Why am I telling it as random variable is like that, it's its own random variable, right? You have a random experiment here that after that the value it takes is its own, is what I mean. and all these random variables are equivalent, like d1 is equivalent to d2, d2 is equivalent to d3, like they are no different from each other. That's why I'm trying to call them as random variables, and then I'm trying to see that these two are equivalent, like you can see that, right? A0 and a1 might differ, but d1 and d2 are, like, in terms of their random things, they are equivalent, right? Now try to imagine that you are expanding this shit, okay? If you're expanding this shit, how does it look like? How does it look like? I'm not sure if it is right or not, but let me try some more time. Plus, everything like this thing, like, doesn't have any d power, or exclude 1a, and then you have d power 1. Exclude 2a, and then you have times d power 2, and so on. I think this would be the expansion, I guess, right? nc 2 times, n times. But excluding 1a will all automatically have that nc1, because you'll exclude this, and the next time you will exclude this, so it will have nc1. Excluding two things will already have that uh, nc2 component here, and so on. This can be in one way to write it, to represent this d, because the d is an independent random variable, I guess, because d1 times d2 plus d2 times d3, all of them are pluses, right? All of them are pluses, and with linearity of expectation you can take expected value of this, and expected value of d1 d2 would be equal to expected value of d2 d3, because what, d1 and d2 and d2 and d3, I think all of them are like very same, right? So expected value of d1 and d2 and expected value of d2 and d3 is same. That's why we can finally write them as, with linearity of expectation, we can add all of them, and then you can write it as d power 1 d square up to so on. Okay. Now, can you get these values quicker? How much time can we take? Okay, n is 2000, q is 2000. Maybe if you can get these values quicker, you can do it. And things, right? Maybe if you can get these values quicker, you can do that. Maybe if you can get excluding one thing, 1a, what is the product? Excluding 2a, what is the product? I think if you can get all of them, maybe then you can independently find d power 1 d square up to so on, right? Expected value is probability of this being d1, this being d2 up to so on, this times this value. That summation is that. But I'm trying to write it like a linear, like, I'm trying to write it like a random variable, and then I'm trying to find expected value of this, and then I wrote it like that, and then when I have expanded, expected value of d1 d2 is same as expected value of d2 d3, so and then I'm writing it as d power 1 or d square up to so on. Okay, now if you can get this, if you can get this, maybe in n square you can try to solve the problem, I think, right? All you have to do is k is very big, so you have to find d power thing when k is very big. I think let's try to think of this thing. How difficult is it to find excluding one thing? Okay. Let's say you found all of these things without an. Okay. You found it without an included. You found it excluding none. Okay. Excluding one. Okay. And so on. Okay. So now you can find them again. Excluding none, you can try to use you must involve an, so you have it by multiplying an. Okay, in excluding one, you can use an times excluding one in previous, plus, because an is involved and now an is missing, plus excluding none. I think in this way you can try to proceed and find all these constants using an seems reasonable, right? You want now excluding two things. Excluding two things will become, among excluding two things, an is not present, which is nothing but excluding two things from previous. Sorry, among those two things, an is not present. Means an is present here. Means if an is present, you have to exclude two things from the remaining things. So it is excluding two things from remaining things like the previously. Plus now n is not included. Let's excluding one. So this constant plus n times this constant gives you this constant. That's it. So you can find all those constants. Okay, you can find all those constants. So now we have to only focus on expected value. So it's all about this d1, d2, d3. These things are like identical. That's the main idea. That's being the main idea. Expected value of d power I. Okay, where d1 plus d2 up to so on d n equals to k. This is the random thing. You want d power i's expected value. Okay, you want d power i's expected value for any of that. For any of that. Let's look at 1D. Let's look at 1D. What is the value? What is the expected value that, let this be x, okay? If what is the probability that d1 equals to 0? It is kcn, I think, right? None of them is falling that. Like we have k independent balls, all of them going to something else, which is none of them falling in this box. N minus 1 power k by n power k, because all of them can go to n places, but all of them has gone to only these places. So this is more like a, this is more like a, I don't remember terms. I think we have this binomial, uh okay, yeah, the probability to fall, so for a one ball probability to fall it into d1 b p, that is 1 by n. Not falling is, let it be q, that is 1 minus 1 by n. Okay, now d1 being 0 is nothing but, what is the probability of that? nc 0 times p power 0 times q power n. Okay, sorry, kc 0 times p power 0 times q power k. d1 being 1, what's the probability? kc 1 times p times q power k minus 1. So this would be the values of d1, but then we want expected value. These are the probabilities. We want expected value of d1 power. You don't want this times d1, but you want this times. Okay, so if you see that as I, it is kc I times p power I times q power k minus I times, what do you want is I power k. This is what you want. You want d1 power x, let's say. Yeah, you want I power x. Okay, you want this value. I power x is a constant. Okay, I is varying. I is varying. How do you get this shit? Maybe there is a simpler way on that. Like, what is a small number here? Maybe you can find this thing again, like first few things and then the next thing. Here they are equivalent. D1 is not D1 times D1 is not equivalent to D1 times D2. Okay, because there you cannot D1 are same things. D1 D2 are different things, right? This distribution is called some distribution, right? Bernoulli's distribution. Do we have something for Bernoulli's distribution? Expected value of power x, like power of the value. Do we have something like that? Do we have something for this x? When x equals to 0, the expected value is, this is just 1, right? When x is 0, that is just 1. When x equals to 1, do we have some formula? When x equals to 1, can you make it like, can you expand this formula like k minus 1 by I? Okay, then it becomes p power, also take p outside, then becomes p power I minus 1 q power k minus 1 minus of I minus 1, let's say, and then I power x. If x equals to 1, you can see that, you can see this as these two being cancelled, okay, and k minus 1 times p being occurring. If x equals to 1, that is k minus 1 times, I think it's like differentiating or like integrating or something like that. You have to differentiate it and keep x equals to 1, I think, because then you get I down, and then you have to again multiply by x, and then again you have to differentiate. Or you can try to use this for such a formula. But what's the difficulty in using this formula? I'll send Happy New Year, guys. Fuck. So, guys, how to do this thing? Like, how to see this well? This Here I goes from 0 to that value, right? So I will just remove 0 to k minus 1, right? I'll just remove, sorry, this is k by I. times k minus 1 c I minus 1. I'll just write I equals to 0 separately. Okay, if I write I equals to 0 separately, this will become q power k. Oh, I equals to 0. I equals to 0 is 0 anyway. I equals to 0 is 0. So it will become k by I times, not I equals to 0. Okay, I equals to 0. I equals to 0 is 0 anyway. So it will become k by I times k minus 1, c minus 1, p power p times 2. P also comes outside. Okay, k into p. K into p times by I, all of this thing. And then that by I will go to x minus 1. Okay. And this here, we know that this value equals to, this value equals to, so let this be expected value of d power x. That is the value, right? We are only keeping I equals to 0 aside, and then we are able to write that as equals to k times p times, this is nothing but e of d power x minus 1. So we know e of d power 0 equals to 1. So answer of e of I power k equals to e of d power x equals to likely wait, this is x comma k, and that became equal to x minus 1 comma k minus 1. We have to be careful here. Okay. So what will d power x will become? D power x comma k become. It will become k times p e power, let's just call it x minus 1 comma d minus 1. Sorry, x minus 1 comma k minus 1. So how does it go? Is it like k into k minus 1 times k minus 2 times up to so on? What happens if k becomes 0? If k becomes 0, d is 0, and then expected value is 0. But I don't think we go there. Is there a formula already? When k equals to 1, when k equals to 1, I think when k equals to 1, you cannot write something. Okay, we can go till k equals to 1, let's assume. Okay. So when k equals to 1, what would be the value of this? When k equals to 1, you know the probability of this being 1 is p. So if k equals to 1, p over x. So now how do you see this? K minus 1 up to so on 1, let's say. Up to so on 2, let's say. And then you have e power. Guys, am I doing something wrong? Do you guys know the formula for this? I think this is correct. It's like differentiating it like you have 1 plus. You have like q plus px, let's say. Q plus py whole power n. Whole power k. You're differentiating it x times, then that I drops down. You have to multiply with px. So this p getting multiplied, that I gets drops down. And so on till where do you go? Till where do you go? Either k becomes 1 or x becomes 0. Let's try to see both cases, okay? When k becomes 1, what happens? We have reduced minus of k minus 1, right? So it will be p power k factorial times p power x k minus 1, right? Each time. Okay, now you have left with this. And then what do you do? This will become p power x minus k plus 1. So this will just become k factorial times p power x. Okay, if it becomes x becomes 1 first, let's say. What if x equals to 1 or x equals to 0? Let's say x equals to 0. If x equals to 0, the value is 1, right? E of 0 comma k equals to 1, let's say. If x is becoming 0 first, then what can we say? equals to e of 0 comma k minus x. And then we have here k into k minus 1 into up to so on k minus x plus 1 times p power k minus x. But is this correct? Should be correct. Is this formula actually like this? Doesn't make sense somehow. I'm sleeping, guys. I think that's how this is done. I'll Google it. Yeah, this is what it is. Huh? Yeah, 0 or 1. But it doesn't take 0 or 1. Here it takes more than that. This is that differentiation thing, I think, moment generating function. To differentiate twice, we have this shit. What the fuck? Yeah, so I think this is not possible. This is not possible. We have to do something else. Maybe we can brute force on something, yeah. Because it doesn't simplify. Probably n and k or n and q are small, right? with that we can try to do something else. I think we can maybe fix some value and then we can try to see number of different things that are possible for some other thing. Yeah, I think yeah, someone else told the solution already. I think you can try to find expected value, or like you can try to fix one thing and then you can try to find whatever is the product and summations of the other things being this much sum, and then you can try to find the problem. I think that's how it does. Like I was trying for a closed form, I guess, so I complicated the problem. Okay, I was trying to form something small and simple, but then you need not do all of that. You can likely expand it like till here, try to find for summation equals to k, but k is not small, right? Should I solve the problem somehow? I'm leaving the problem, guys. Bye.